Welcome to day number 2 or video number 2 or session number 2 or however you're going through this AIM program. Today is going to be our first day of some actual math stuff, fractions and decimals, not especially difficult in any way. As I mentioned in the previous video, I expect that you've seen all of this before and you've learned all of the stuff that I'll show you today in the past. Just maybe you're kind of just want a bit of a refresher. We want to be able to work on it quickly, that kind of thing. All right, so let's just do a quick review. From our previous day, it was just vocabulary and an outline of the program. So add, subtract, multiply, divide, addition, subtraction, multiplication, division, like that. Those are the 4 kind of basic operations. When we're actually reading an equation and we have the symbols there, so plus, minus, times, multiplied by, or divided by. And the results, if we add 2 things, the result is a sum. If we subtract 2 things, the result is a difference. Multiply, product, divide, quotient. Negative numbers, whatever, or for reading an equation like negative a minus b, like that. So negative minus should be read differently. Brackets and parentheses, we don't usually need to say those words out loud, but we should be able to talk about them. We don't read them out loud when we're actually like just reading off an equation, but sometimes we have to specifically mention them. And then reading fractions, something like 3/2 for a fraction, or 1.5. Hopefully you see those expressions and right away, gotta make sure I snap on camera. Hopefully you see those and right away you know what those look like. Today, a bit more vocabulary. It's listed on the right there. I'll go through that when we get to that material. Simplifying fractions, adding and subtracting fractions, multiplying and dividing fractions, simplifying complex fractions, converting between fractions and decimals. And then I'll give you a whole bunch of practice exercises to work on. So that's the plan. Before we get started, just want to remind you of the goals of this program. So our AIM Accelerated Intensive Math program. I came up with the name AIM first and then what it represented afterward. I had to remember. So AIM goals here. So being able to talk about, listen to lectures and explanations of math in English, and you are familiar with all the terminology, at least for kind of the basic operations. Second, that you are able to do all the stuff we're going to see in this program quickly. Again, you've probably learned all of it before, but we want to just, if it's been a while since you've done a math class, then we want to be able to just refresh that part of our brain, kind of wake it up again, make sure we're able to do all this stuff quickly. So not just accurately, but also quickly and without a calculator. Because simple operations like we'll be seeing, you can work through them pretty quickly on paper or just in your head. We want to get that math part of our brains working again. All right, so vocabulary. First, for today, we are going to need, these are from last time, just since we're talking about fractions, I'll just do a proper review here. A over B for reading a fraction, just because it's sort of physically over the other one, just sort of a visual description. If we have numbers, though, we can also read it like this: 5/7 or 2/3 or something, or 3/100. So 5, the first number would be the top number as a cardinal number, like 1, 2, 3, 4, 5, like that. And second number on the bottom would be read as an ordinal number, like first, second, third, fourth, fifth, like that. In a math class, something like 5/7, that's fine. Just sometimes you'll hear people say it like this, cardinal ordinal, so you should be familiar with that type as well. All right, that was from last time. For today's new vocabulary, so numerator and denominator, so the fancy names for the top number and bottom number of a fraction. I will, like, honestly, in this program, I will probably just say like top number, bottom number, just to make things easier. But sometimes the word denominator does come up. I'll use that a little bit. So good to know these fancy terms here. Second one, if we have a fraction and we flip it upside down like this, that is a reciprocal. So the reciprocal of A over B is B over A. So that's basically means the opposite of something. So reciprocal is specifically when we're dealing with fractions, but in more general and other math contexts like addition and subtraction are inverse operations. One is the opposite of the other. Multiplication and division are inverse operations, that kind of thing. So reciprocal or an inverse. Those are both words that we could use to describe the situation. Inverse is a noun. The verb here would be invert. Invert. So that will come up as well. And last one, we're going to talk about if we have a fraction like this and it isn't the simplest form, then we could simplify the fraction or reduce the fraction or expression or equation or whatever to the simplest possible form. So those are some terms that I will be using today. All right, moving on to our first math thing, just starting off nice and simple, simplifying fractions. By the way, these are all from, you can always see here, all the questions I'm using are from the textbook one of the textbooks that I talked about. It'll be kind of a mix, but it'll always be listed here, and then on each actual day, you'll see right at the top here, this textbook and this exact example. The example numbers are independent of the chapters in the book, so there's only one example in the book called 1.24, so just find that example and you can see a more detailed description of what I will be doing. All right, so simplifying fractions, just kind of intuitively, we want to look for a common factor, another term here. So a shared factor. So a factor is, a common factor is any number that can evenly divide both of these. So first we can just look for actual factors, like 315. Well, what can we evenly divide that by? Just intuitively in your head, you can probably see some stuff. So let's jump right there. So let's say 315, well, I can obviously divide that by 5 here. So 5 times whatever. 5 times 60 would give me 300, and 5 times 3 would give me 15, so 5 times 53. And 770, that's going to be just, well, 10 and 77. Okay, split them up into some factors. No common factors yet though, so we can do a bit more. 63, that is 7 times 9. 10 is 2 and 5. 77 is 7 and 11. Okay, so 7 on the top and bottom, those cancel out. 5 on the top and bottom, those cancel out, or they eliminate each other. And then we're left with a 9 on the top. So -9 over, and 2 times 11 on the bottom, that's 22. So there's our Final answer, -9/22. Okay, so simple. So this is me giving all the kind of detailed explanation in case you completely forgot how to do this stuff. Next, I will do just another example, exact same type of question, and it's this here. I'll go through this more quickly, just at a natural speed for me, and then there'll be one more example, and then that's your turn, the one for you to do. All right, so -69/120, we can see on the top here, definitely a factor of 3. So 3 times something, 3 times 20 would be 60, and then 3 there, so 23. And on the bottom, 120, well, that's 10 and 12, and -3/23. 10 is 3, 4, okay. So 3 cancels out. 23 is a prime number, so 10 we can split up more, but 23 we're kind of stuck there. So -23/40. That looks like that's the simplest possible form of this. That's a 40, not a 46. 40. Okay, so that was my turn, and now it's your turn with just the very next example from the book, that number. So that's you. I'm going to disappear for a few seconds, pause the video, solve it, and then we'll come back and I'll show you just the number, not the process, just the final number. Hopefully yours is the same as mine. All right, go ahead. Okay, the answer that I got for this one was -5/8. Hopefully you got the same number that I did. If you didn't, try the question again, or pause or go back and re-watch those examples in the process and check your work on that. If you do need more detail and more explanation, again, in the textbook, this example, 1.24, there's a very long, detailed explanation. We will go over some kind of tricks and some shortcuts to help do these kinds of things, but still just intuitively you can look and say, okay, I think I see a factor there. Let me just try this. There's smarter strategies, but still the basics you should be able to do. All right, next topic is adding and subtracting fractions. Again, still nothing too hard today. Just being able to do this stuff quickly, comfortably, easily. So if we have something like this, 7/12 plus 5/18, then I want, where's the term? I want to have, there we go, a lowest common multiple. So lowest common multiple would be multiple of a number is that number times 2 or 3 or 4. So multiples of 3 are 6 and 9 and 12 and 15 and 18, etc. So we want to find the lowest common multiple between 12 and 18. How can we do that? We might notice here if we did 12 times, right color, there we go. 12 times 3 and also 18 times 2, those would both give us 36. So we would change both of these fractions into something over 36. And then if the denominator, the bottom numbers are the same, then we just directly add them, add the two top numbers. So 12 times 3 gave us 36, so 7 times 3, got to keep everything balanced. 7 times 3 would give us 21. 5 times 2 gives us 10, so 31 over 36. And we can't simplify that at all. We're just 31 is a prime number. We can't touch that really, so there. That's the simplest possible form. And we're done. All right, so just make the bases, the bottom numbers, the denominators the same, and then you can add or subtract. So I don't have a separate example for subtracting, but it's the exact same process, except you're just going to subtract the two top numbers. Excuse me. All right, so next. 2 more examples. First one is my turn, second one is your turn. The other thing that we can do here, if we don't immediately see a common multiple, then we can always just multiply the two bottom numbers together. 12 times 15, 12 times 10, 120, 12 times 5, 60, so 180. So common multiple, it might not be the lowest, but it is a common multiple, 180. 180, so to get 180, we did this times 5, so top times 5 here would be 35. Sorry, that's not 5, that is 15. Try that again. Times 15, 7 times 15 is not 35, it is 105. It's better. And the other one here, 15, we did times 12 to get 180, so 11 times 12, 12 times 10 is 120, plus one more 12 would give us 132. And just add those, and we will get 237. Okay, so we did not find the lowest common multiple between 12 and 15 necessarily. So it's possible that we can simplify this, and in this case, actually we can. So 237, we can recognize that that is divisible by 3. We can divide that evenly by 3, so we're going to divide the top and bottom by 3, take out a common factor of 3, so that will give us, let's just write this with an extra step, so 3 times 60 on the bottom, and 3 times something, 240 is 3 times 80, so 237 would just be 3 times 79. So then the 3's are canceling each other out, so there we go. 79 over 60. If we want, we could have written this as a mixed number, like 1 whole plus 19 60ths, this many parts as well. Doesn't matter. But we do want to simplify. If we have something, a common factor, we want to show our answer in the simplest possible form. Okay, that was my turn, and your turn. All right, and let's show the answer here, which I worked out in advance, and I found that it was 103 over 60. Let's check my notes. Yep. Hopefully you got the same thing. All right, next topic, multiplying and dividing fractions. I guess just quickly, if you feel like you want more practice about this, at the end of this video, I'll show a big long list of possible practice questions you can do from our textbook. So there's lots of practice if you need it. Multiplying and dividing fractions. So we'll do some examples of multiplying and then some examples of dividing. All right, so negative 12 over 5 times negative 20x. So hopefully we all recognize that this is actually a multiplication happening here. So times negative 20x. Okay, so it is just the 12 times the 20x there, but just in case, we can always take something like this and rewrite it as a fraction. 20x over 1, like this. So if you see it like this, then maybe it's a little easier to think about. You multiply the two top numbers together and multiply the two bottom numbers together, and that will give you your results. So here we will have, I'll just rewrite this as an extra step. Negative 12 times negative 20x, and on the bottom, 5 times 1. So on the top here, that is going to be 480, sorry. I'm remembering the answer, and that's messing me up. 240 here. 240x, the two negatives are canceling out here. And then on the bottom, that's obviously just 5, and we can simplify that. 240, we can divide that by 5. So divide it by 10 would be 24, times 2 would be 48. So there we go, 48x. And there's our answer. So just multiply the two top numbers together, two bottom numbers together, and that's multiplying fractions. All right, we'll erase, and next one. So my turn first. There. All right, 11 times negative 9a will be negative 99a over 3, and we can simplify that to negative 33a. And done. All right, that was my turn. And now your turn. All right, so answer here, 13 over 7 times negative 14b. Answer was, or is, negative 16b. Hopefully that's what you got. All right, let's clear that, and I have a division example next. So if we are dividing fractions, it's very similar to what we just did. So here, negative 7 over 18 divided by negative 14 over 27. Two ways that this is usually talked about or taught in English. So cross multiply. Instead of with multiplying fractions, we multiply just across, the two top ones together, two bottom ones together. Excuse me. For dividing, we kind of cross multiply, take the top one on one side and multiply by the bottom one on the other, and then the bottom one on the first one, top on the other. Instead of that, I usually like to think about this as invert and multiply. We take the second fraction, flip it over, invert it, and then we multiply, change the division to multiplication. So negative 7 over 18. And if we invert, so change this to multiplying and flip this, we'll change to negative 27 over 14. All right. So now we could just multiply here, of course. So negative 7 times 27 and 18 times 14. But why not simplify first before we do the multiplication and then have to simplify afterward? Here it's a little easier to see. We have a 7 on the top and a 14 on the bottom, so that just simplifies to a 1 and a 2. And negative 27 and 18 here, so 27 over 18 is just 3 over 2, so that's, and the two negatives are canceling out here. So 1 times 3 over 2 times 2, so 3 over 4. There's our solution. So invert and multiply is the process here. Little sort of side question for you. Why do we invert and multiply? Why does that work? There's a fun little proof. It takes like 2 minutes to do. But you can probably figure it out for yourself. Use just the basic rules of multiplying fractions and then try to prove to yourself, convince yourself that this invert and multiply process actually works. Okay, so there's the example, invert and multiply. Let's erase my turn here. So negative 7 over 27 times 36 over 35. And if we simplify 36 over 27, that's a 4 and 3. 7 over 35, that's 1 and 5. So that gives us, so I forgot the negative sign here. Negative inside the brackets. So both terms are negative, so our result is positive. So we will have 4 over 15. There's our result. And can't simplify that any further. Okay, that was my turn. And now your turn. Okay, and results answer here. Negative 5 over 14 divided by negative 15 over 28 is positive 2 over 3. If the English part of this is practice for you, then do what I'm doing and try to like actually just read this out in your head. You should be able to talk about this verbally and like describe what you're doing to a person, even if they can't see your paper or whatever. So make sure you're actually practicing the talking part as well. All right, I think we have 2 more. So simplifying one more after this. So first, simplifying complex fractions. This is basically the whole invert and still just dividing fractions, inverting and multiplying. Hopefully when we see something like this, we recognize that we have like 1, 2, kind of 3 fractions going on here, and we have sort of our order or our priority. So x over 2, xy over 6, and then kind of after those, then we have sort of this larger fraction happening here. We can't just randomly change the order with division. But we can rewrite this and make it a bit easier to think about. So let's write this as x over 2. A fraction is the same as dividing, divided by xy over 6. Okay. So then it's the exact same thing that we just had. So inverts x over 2 and multiply 6 over xy. X's are going to cancel out. 6 is going to turn into a 3. 2 is turning into a 1. So that is 3 over y. And that's as simple as that's going to get. So there, solved. So if it's a big, crazy looking fraction, just kind of rewrite it in a way that makes it easier to think about, and then it'll be easier to solve. All right, my turn here with the two practice ones. A over 8, divided by a b over 6, a over 8 times 6 over a b. A's are canceling out, 6 and 8, that's going to turn into a 3 over 4, and a b on the bottom. 3 over 4b. Done. All right, and your turn. P over 2 over PQ over 8. Go ahead. Okay, answer here is, according to my notes, 4 over Q. So hopefully you got the same answer for yourself. All right, last one here. Converting between fractions and decimals. So we'll kind of do the first half now, from a decimal to a fraction. So let's say we have something like this, 0.374, and we want to write it as a fraction. So steps, just write it as a fraction over 1. Well, that's very easy, 0.374 over 1. Doesn't change anything. Multiply to remove decimals. So 0.374, if we want to get rid of the decimal there, we're just going to multiply by 1,000. And if we do something to the top, we must do the same thing to the bottom, keep everything balanced. 374 over 1,000, 374 over 1,000. But we can simplify this a little bit, so let's do that. So I don't see a factor of, like, obviously not 5 or 10, not 4, but at least 2. We can take out a common factor of 2 here. So 374 divided by 2. If I look at the complement with 400, that's 26. Half of that would be 13, so 200 minus 13 would give us 187. And divide the bottom by 2 as well, 500. Don't think we can go further. Can't divide that by either one by 3, not by 4. If we think of the factors of 500, none of them are going to work with 187. Again, there'll be a day or two when 2 days later, 3 days later, when we talk about sort of strategies about how to do this stuff and what to look for and how to find some shortcuts. But again, you probably know some of those already, so see if you can find any factors. Reduce in whatever method you want. Okay, so let's just do one more. My turn here. So 0.234 over 1. And then multiply both by 1,000, 234 over 1,000. Divide by, not 4 is not going to work again, but we can at least do 2. divide by 2 would be 117 on the top and 500 on the bottom. And 117, we can divide that by 9 actually, but we can't, and by 3, but we can't divide the bottom by either of those numbers. So again, here I think that's as far as we can go. Okay, that's my turn, and your turn. 0.024 as a fraction. Okay, this one, if we simplify this as much as possible, will turn into 3 over 125. So hopefully you were able to reduce it that much. Okay, that's I think. Right, little preview here. Forgot I had this. The other part, if you were looking at these questions in the textbook here, is the other direction from a fraction to a decimal, which is not too bad, but we do require long division to do this, and that seems to be a thing that some people have not used for a while and might have forgotten. So the next class will be talking about long division, and that's when we will do it. So next time we'll get to that. All right, just some things, some numbers here that might kind of be useful for you to remember when going from fractions to decimals, or both directions. So like, 1 over 2 is 0.5. I think we remembered something like that. 1 over 4 is 0.25. 3 over 4 is 0.75. 1 over 5, 0.2, 2 over 5 is 0.4, 3 over 5, 0.6, like that. So some easy ones. 1 over 8, probably you know or have remembered. So 1 over 8, 0.125. 3 over 8, 0.375, 0.625, 0.875 here. We also have a bunch that are infinite decimals. So 1 over 3, for example, is 0.33333 to infinity. So we can write that with a little bar over top like this to show that it's an infinite decimal. 1 over 6 is 0.16666, like off to infinity. So a little bar over that one. 1 over 7, good to know also, it's 0.142857. And then that repeats 142857, 142857 off to infinity. So it's a longer repeating thing, but it's not huge. It does repeat. 1 over 9, 0.1111. 2 over 9, 0.2222, like that. 1 over 11, also that comes up. So 0.090909. 2 over 11 is 0.181818, and 3 over 11, 0.2727, like etc. And we won't get to roots for a while, but square root of 2, also quite handy to know. I find this comes up quite often. So 1.14142335. This does not repeat. This is just an irrational number. It's just all different things, but at least like the first kind of few positions of this, like this much, very useful to remember, I'm gonna say. Okay, so there's just some tips or some recommendations here. You probably know most of these, but just good to have memorized and just kind of be ready to use them whenever. All right, so practice exercises There are a lot. I do not expect you to actually go through all of them, just the ones that you think you need to do. For example, so if you saw the part about simplifying fractions, there are a whole bunch of them here to work on. If you see that and you say, wow, this is a really easy topic for me, I don't need practice on this, I'm very comfortable with this and I can do it quickly, not just accurately, but also quickly, then don't do those questions. Like, you should know if you are comfortable with these things or not. Adding and subtracting fractions, if you can do that quickly, then okay. Then don't work on those. But if it's something like you can do it, but it's kind of slow, the arithmetic, the adding the numbers is kind of slow for you, or finding the factors is slow for you, then just practice. Again, I'm sure you know how to do these things, but it's being able to do it quickly, comfortably, without a lot of like mental strain. So practice. Multiplying and dividing fractions, bunch of questions here, simplifying complex fractions. And then after those, there's just a bunch of sort of mixed practice. It's on all sorts of different things within this set here. So if you think you're comfortable with all of these, then just take a look at some of these mixed practice and make sure you're able to go again through them quickly and accurately. The textbook has answers for all the odd numbered questions, have answers in the back so you can check your work on everything. Excuse me. And then from chapter 1.4, these were from 1.3. From 1.4, there's a few more here about converting decimals to fractions, but we'll have more about that tomorrow or in the next video, whenever you watch it. Okay, so keep yourself honest. Don't just say, well, I don't feel like practicing, and then don't do it, because then this whole thing is just a waste of time. Like, if you're very comfortable with it and you're confident, then okay. But if you're not like 100% confident you can do this very quickly and easily, then do the practice. Actually check your work. Okay, wrapping up. So vocabulary we talked about today is here on the right. Numerator, top number, denominator, bottom number of a fraction. A reciprocal is a flipped over fraction, the opposite fraction, or more generally we have these words inverse and invert. We simplify or reduce a fraction or an expression to just be the simplest possible form. Common factors, any number that can evenly divide two other numbers or three other numbers, multiple other numbers. If it can, then we can kind of cancel out those common factors or eliminate them to simplify whatever we're working on. With adding and subtracting fractions, we want to find the lowest common multiple. If you don't find the lowest, then you just kind of multiply the bottom numbers, get your result, and then afterward you're going to have to simplify. So if you can find the lowest common multiple, you just save yourself some work. All right, simplifying fractions, adding, subtracting fractions, multiplying and dividing, simplifying complex fractions, converting from fractions to decimals, and we'll do the other direction in the next thing, the next day, the next video. And lots of practice questions for you to work on. Tomorrow, next video, we are going to do long multiplication, long division, and then have some practice questions for you to work on. So that's it, and that has been day 2 of this program. So thank you for watching, and I will see you back here whenever you're ready for the next part. Goodbye.